Hello viewers, welcome to Elimu TV. My name is Mr. Nginya, teaching Form 2 Physics. Our topic of discussion remains magnetism, and kindly let me know that we are in class together by sending an SMS saying I'm in class to 21450. Kindly send an SMS indicating that I am in class to 21450. So our topic of discussion, as I've said, remains magnetism. And during the last lesson that we had, we discussed the domain theory of magnetism. We discussed the domain theory of magnetism, where we said that all magnetic materials consists of small magnetic groups called domains. All magnetic materials consists of small magnetic groups called domains. And inside of these domains, we have subatomic magnets called dipoles. Remember I said domains will vary in size and shape. And we also said that the dipoles inside a domain will have a common magnetic axis. The dipoles inside a domain will have a common magnetic axis. It is such that when in the unmagnetized state, any magnetic material, for any magnetic material in the unmagnetized state, the dipoles form a closed loop. The dipoles will form a closed loop. Then when this material is magnetized, then most of the dipoles align themselves such that they have a common magnetic axis in that they point in a particular direction. Then if this material is completely magnetized or it is fully magnetized, then all of its dipoles face a particular direction. Then at such a point, then that material is said to be magnetically saturated and no further magnetization can take place. For today, I would want us to explore the various ways which can be used to create magnets. So our topic today is magnetization. Our topic today is magnetization. What is magnetization? Magnetization is simply a process which can be used to make or to create a magnet. Magnetization is that process that is used to create a magnet. On the onset, what you should note is that you can only make a magnet from a magnetic material. A magnet can only be made from a magnetic material. Magnetic materials, if you recall, are materials which are attracted by magnets. Example, we have steel and we have soft iron and alloys of nickel and others. So we have a magnet can only be created out of a magnetic material. Now, the process of magnetizing simply involves aligning the domains, aligning the dipoles such that they get a common magnetic axis. Aligning the dipoles such that they get a common magnetic axis. And when that is achieved, then we can say our magnetic material has now been magnetized. So basically, we have four methods that can be used to make a magnet out of a magnetic material. We have basically four methods or four ways which can be used to make a magnet from a magnetic material. One of these methods is called induction method. One of the methods is induction method. Induction method. The second method which can be used to make a magnet is called stroking. The second method is stroking. Then the third method that can be used to make a magnet is hammering. Hammering. And the fourth method that can be used to make a magnet out of a magnetic material is the electrical method. We have electrical methods. So basically, these four methods can be used to make a magnet. The induction method, the stroking method, the hammering method, and lastly, the electrical method. So we are going to explore how each of these methods can be used to make a magnet. And we are going to start with the induction method. So in the induction method of making a magnet, what you need is the material to be magnetized. You can take, for example, you want to magnetize a steel needle. You need the material to be magnetized, and you also need a permanent magnet. So you need the material to be magnetized, and you also need a permanent magnet. I have the two with me here. So we have a permanent magnet, and we have the steel needle, which is to be magnetized by the induction method. So the method of induction is a very simple method. What you need to do is that you take the permanent magnet, you can hold it vertically, the permanent magnet, then the material to be magnetized by the induction method is attached to the lower edge of the magnet. So it is attached to the lower pole of the magnet, be it the north pole or the south pole. And when it is attached to the edge of the magnet, the object is attracted. The object is attracted by the magnet. When that happens, if I have used the north pole of the permanent magnet, I want to magnetize this one, or this pin, by the induction method, then the edge of the pin, which is attached to the magnet, will acquire a polarity opposite to the pole on which it is attached. Which means, if this is the north pole, this edge of the pin, which is attached to the north pole, acquires a south polarity. Therefore, it becomes a south pole. Which means the lower edge of the pin will acquire a similar polarity to the polarity of the magnet being used in the process of magnetizing. Suppose I have another pin. Suppose I take another pin and attach it to the first pin. If I have another pin and attach it to the first pin, then as we can see, the first pin behaves like another magnet, where it is also able to attract a second pin which is attached to it. So you have, if you detach the pin from the magnet, we can see that the second pin remains attracted to the first pin. However, this only lasts for a short while, since this pin will lose its magnetism with time, which means that when you magnetize a material by the induction method, the magnetism it acquires is only temporary. The magnetism it acquires is only temporary. So there are a number of things that I would want us to explore further. When if you have two pins, you attach them to the same pole of a magnet. As we can see, the lower edges of the pins repels each other. When two pins are magnetized by the induction method using the same pole, then we can see that the lower edges repel each other. As I said earlier, the pin or the edge of the pin attached to the magnet will acquire an opposite polarity, which means if this is the north pole, then this top edge of the pin would be south poles, which makes the two lower ends of the pins to be north poles. And remember, from the basic law of magnetism, like poles repel. So this north pole of this pin repels the north pole of this other pin. Again, observe what happens if a north pole of a second magnet is brought close to this one. If you bring another north pole, then as we can see, the edges repel further. So you have, if another pole similar to this one is brought, then you have, there is more repulsion. There is more repulsion, indicating that these two poles are similar poles, indicating that these two poles are similar poles. So basically, that is the first method of magnetization, the induction method, where we have said the magnet created by induction method only retains that magnetism for a short while. Therefore, it's a temporary method, or it acquires temporary magnetism. It acquires temporary magnetism. Let us now look into our second method of magnetization, which is the hammering method. So when the material is to be magnetized, when a magnetic material is to be magnetized by use of the hammering method, here we are basically exploiting the magnetic properties or the magnetic field of the earth. Remember, we had earlier seen that the earth in itself is a big magnet whose magnetic field is uniform. So when you want to magnetize a magnetic material by the hammering method, we exploit the magnetic field of the earth. Here, what you need is the material to be magnetized. For example, you want to magnetize a steel bar. So the material to be magnetized and a hammer is all what you need to create a magnet by the method of hammering. So the material, suppose you want to magnetize this steel needle, then you also need a hammer. So the material to be magnetized and the hammer. And the process is very simple. Place the material to be magnetized in the north-south direction. You place it facing north-south direction. Then with your hammer, you strike several times. You hammer your material several times. As you hammer, the dipoles in this material are made to align themselves following the Earth's magnetic field, such that they are aligned in the north-south direction. And remember, when the dipoles in the domains get that magnetic axis north-south, then a magnet is created. So again, you take the material to be magnetized, then while facing north-south direction, you hammer it several times. And when it is hammered several times, then that material acquires some magnetism. So basically, that is our second method of magnetization, the hammering method. We can now look into our third method of magnetizing, the stroking method of making a magnet. So here, what you need is one, the material to be magnetized, which we said must always be a magnetic material. Suppose I have a soft iron pin, or I have a steel pin, which is to be magnetized by using the stroking method. As you're going to see, we have basically two types of stroking. Starting with the first one, the one we call the single stroking method. We can start with the single stroking method. In the single stroking method, you need the material to be magnetized, which is placed on a bench. When you place it on a bench, then you need a permanent magnet. We only use one pole. You may decide to use either the north pole or the south pole of the permanent magnet. The material to be magnetized is stroked along its whole length. So you stroke the material along its whole length, lifting the magnet at the other edge, such that you form a loop. So you stroke the material along its whole length, then you lift the magnet, forming a loop, and start again from the other side. Then remember always to maintain the inclination or the angle that the magnet forms with the material which is being magnetized. So you stroke along its whole length, lift the magnet at the extreme edge, again repeat that several times, forming the loops. You stroke, forming a loop. Then after doing that several times, then you can test your material, and you'll find that your material will have acquired some magnetism. So the magnetism will have been acquired by the single stroking method. The main disadvantage of magnetizing by stroking method is that you'll create a magnet where one pole is nearer to the edge of the material than the other, such that if this is the south pole, then the south pole will be at the edge, but the north pole will be not at the extreme edge. You'll find that it will be somewhere allowed the middle of the material. So that's the main disadvantage of the stroking method. Again, after testing the polarity of the material, it is observed that the edge of the material which is last touched by the magnet will acquire an opposite polarity. We have the edge of the material last touched acquires an opposite polarity. That is to say, if this is the north pole of the stroking magnet, then this edge of the magnet will be a south pole. This edge of the magnet will be a south pole, meaning that the north pole of this material will be around this region here. So we can first stop there. We have discussed 3 methods of magnetizing. That is the induction method, the hammering method, and the single stroking method. Thank you for watching us. And remember, you can always get fingertips on this topic and many others by sending an SMS, PHY to 21126. Send an SMS starting with PHY, then send to 21126. Thank you for watching, and stay tuned to Elimu TV for much more educational matters. Thank you.